Two prompts can look almost the same size to you and spend very different amounts of model budget. One has plain English, one has weird spacing, code-shaped text, a few uncommon words, maybe an image, and suddenly the usage report is not what your intuition predicted. That gap exists because models measure prompts in tokens, not words. In this video, I want to make that measurement feel concrete. We will walk through what a token is, how tokenizers split text, why the same sentence can count differently across models, and what the API usage fields are actually telling you. Once you understand that, life will be better. Token count controls whether a request fits in the context window, how much room is left for the answer, how expensive a long conversation becomes, and how much extra context your agent attaches. A user might type one short question, but your application can add instructions, examples, retrieve documents, tool definitions, and conversation history before the model ever starts working. The exact field names change by provider, but the shape is consistent. OpenAI, Anthropic, and Google all expose ways to count tokens before a request, and they all report token usage after a request. The important part is that the count belongs to the actual model and request shape you send, not to a generic word estimate you made earlier. A token starts as a chunk produced by a tokenizer. The chunk might be a whole common word, part of a word, a punctuation mark, a leading space plus a word fragment, or a byte-level piece for text the vocabulary does not compress cleanly. After tokenization, each chunk becomes a number. The model is trained to process that sequence of numbers, so counting tokens means counting how many entries land in that sequence. For English planning, people often say a token is around 4 characters, or that 100 tokens is somewhere near a short paragraph. Those numbers are fine for a rough estimate, but they stop being reliable when you care about an exact context limit, an exact bill, non-English text, unusual spacing, source code, or a different tokenizer. Most modern tokenizers are built around subword patterns. During training, the tokenizer learns which character and byte sequences show up often, then gives frequent patterns their own entries in the vocabulary. Common pieces can stay together, while rare names, unusual punctuation, symbols get split into smaller parts. The tokenizer is not reading grammar the way a person does. It is applying learned segmentation rules that were chosen because they represent training text efficiently. This is also why token counts are model-specific. In OpenAI's tokenizer examples, a long English word splits into 5 tokens under older encodings and 6 under newer ones. A simple math expression changes count because spaces are grouped differently. A Japanese birthday greeting becomes much more compact under newer encodings than under older ones. You have to be aware that each model family uses its own tokenizer, and you need to measure with the one you are actually going to call. After the tokenizer, the API does not leave you with a single useful number. It usually separates what went into the model from what came out of it, and your systems add more detail. Output tokens are the visible answer and structured outputs. Cache tokens can show repeated prompt prefixes that were reused. Reasoning or thinking tokens can represent internal work that never appears in the final text, but still consumes budget. If the API gives you usage after the call, why count tokens before the call at all? Preflight counting tells you whether the request is likely to fit and whether the cost is in the range you expect. The actual usage report tells you what happened after generation, including the output length and any provider-specific details. The practical rule is simple. Measure the request you are actually sending, use the target model's tokenizer or count endpoint, include the real system instructions and tool definitions, and treat retrieve context as part of the prompt instead of as free background material. If you rely on prompt caching, which is very common nowadays, keep the stable prefix stable and move changing user content later in the request. If you use reasoning models, do not judge costs only by the length of the visible answer, because internal reasoning can be part of the budget. That's it.